In this video, we're going to go over how to use the basic trig ratios for right triangles. So, in other words, it's an introduction to right triangle trigonometry, or as we endearly call it, trig. So, first we have to set up the rule of the ratios. We have three trig functions we're going to focus on: sine, cosine, and tangent. There are more, but these are just the ones we're going to focus on for this introduction. So we usually abbreviate these down to 3 letters. So their 3-letter abbreviations is just for the first 3 letters of each one of the words, but we still say sine, cosine, and tangent. So we don't say tan, we still say tangent, or we don't say sin, we say sine. So that's just how to write them. Let me draw a right triangle here to show you what each of them are related to. Alright, so if we have a handy-dandy right triangle here, and we've talked previously that the long side, which is always the right angle, is called the hypotenuse. And then the other 2 sides we call legs of the right triangle, and they're still legs, but in this case we're going to refer to them a little differently for the sake of the trig. So the other thing we need to consider here is an angle. So I'm going to call this angle A. The thing that trig does is relate the sides of a right triangle to the angles of a right triangle. Before, when we worked on the Pythagorean theorem, that related the sides. It was all about the sides. It was all 3 sides in that relationship. But here, for the trig functions, it's going to relate the sides to angles, or angles to sides, however you want to say that. So we need that angle A there. And so when we talk about these other 2 legs here, we're going to name them based on their relationship to angle A. So in relationship to our A, this side over here is opposite A, and we've used that language before, but that's what we use for the trig as well. Okay, now again, in relation to A, we want to name this side, and it is adjacent to A. So that's the language we'll use for right triangle trigonometry. Alright, so we have all those named. Now I want to emphasize something. The opposite and the adjacent are based on A. What is opposite and what is adjacent will change depending on what angle we are caring about. So let's say I have this triangle here, and I've labeled an angle B. The hypotenuse is always going to be opposite the right angle. So the hypotenuse is still the hypotenuse. But the side opposite B is that lower side, because it's the side that is on the opposite side of the triangle, as much as that makes sense, from the angle B. And then the adjacent side is the one that's next to B. That's not the hypotenuse, of course. So what's opposite and what's adjacent will move around based on what angle we're referencing. The hypotenuse will always be opposite the right angle, and it is also always the longest side. So we'll get rid of the second triangle, and I'll show you how all this is used inside of sine, cosine, and tangent functions. Alright, so first of all, our tangent functions, our trigonometry functions are functions. There we go, I got it said right. And what we put into the function is an angle. So right now we're focusing on the angle A, and so that's going to be what I put into the function. In other words, what I put into a trig function is always going to be in degrees, because it's an angle. It's a degree measurement. It's not going to be the length of a side ever. And so we don't just talk about sine. That doesn't really make any sense. We would talk about the sine of angle A, or the sine of angle B, or whatever our angle is, but you have the sine of something. It's not just sine. Same thing with cosine and tangent. They need that input. Okay, so what the trig functions are is just a relationship of that angle. The sine of A is going to be a ratio of 2 sides of the triangle. Same thing with cosine and tangent. So sine is going to be the opposite, which I'm going to abbreviate as OPP, over the hypotenuse, which I'll abbreviate as HYP. So this is just the definition of what sine is within a right triangle. So it's just something you have to accept and memorize. And then for cosine, the cosine is the length of the adjacent side over the length of the hypotenuse. And tangent is going to be the length of the opposite side from our angle over the adjacent side. So those are just ratios. Sometimes these are called the trig ratios for sine, cosine, and tangent. And like I said, this is going to be something you just need to remember, are these trig ratios. And because of that, there's some mnemonic devices that have been developed over the years to help people remember them. One of them is to take the first letter of each piece and put it together into an acronym. So if I take each one of those letters, then I get the acronym SO, CA, and then I did it. So that's one way to do it. This works great if you can figure out how to spell SOHCAHTOA. If you can't figure out how to spell SOHCAHTOA, which seems to be my challenge, then you might need a different way to memorize the trig functions. Another one is to make a sentence using the first letter of all of those. And so there's a few of these sentences out there, but the one that seems to be the most memorable is some old hippie caught another hippie tripping on acid. So we're just taking the first letter of each one of those and making it into a sentence. Some people find that helpful. If you do, great. I don't care how you figure out memorizing them, but you gotta know your trig ratios to be able to proceed from here. Alright, so what we're going to do now is look at using these, and we're going to look at using them in three different fashions. The first is just to develop the ratio, and really that's kind of training wheels for the other two, just to make sure you know your ratios. So we'll look at that one first. Alright, so here we go. We have triangle ABC. I'm not really drawn to scale because I'm not that good. And we have the side lengths there in centimeters. And our job is to find tangent of angle A. So this is angle A. And then tangent is the tangent of angle A is equal to the opposite over the adjacent. And so the opposite of A would be the 5 centimeters, and the adjacent of A would be 12 centimeters. Now, if I was talking about angle B, that would be flip-flop. So it's important to know that your opposite and adjacent are in reference to the angle you were asked to deal with. So we get that tangent of A is 5 centimeters over 12 centimeters. Now here, the units are going to cancel out. And this isn't always shown, but that's important to note. Because when we get tangent of A is 5/12, we're getting just a ratio that's just a number without any units attached to it. It's just the ratio. I sometimes call them naked numbers if they don't have units attached to them when we're dealing with geometry, because so much in geometry has units attached to it. So with your trig ratios, that ratio is just the numbers. Alright, so that's tangent of A. Let's look at doing another one. Now let's find sine of angle B. Now to do this, we switch our focus to B, angle B. So that's going to change what we define as the opposite and adjacent, and the hypotenuse is always the same. Alright, so sine of B is going to be the opposite over the hypotenuse. So the opposite of B will be our 12 centimeters, and the hypotenuse is going to be our 13 centimeters. So we get that sine of B is 12 over 13. Now, if you think back to what I said before we started this example, this problem is really just a training wheels problem, where we just show that we know our trig ratios. We've not really found anything useful per se. These ratios are just, an expression of a function in math. When we get to the next two examples, we'll actually use these ratios to find something useful within the triangle. Okay, so here we have a different triangle ABC. And what we're given here is we're given the length of one of the sides, and we're given the measurement of one of the angles, and we're asked to find the length of A. Alright, so the first thing to note here is they're not telling us what trig function to use. We've got to figure that out ourselves. And that may be one of the more challenging parts of this. So the way you figure that out is you look at what you're given and what you're asked to find. You'll always be given two things, and you'll be asked to find one thing. And so that's a total of three things. And those three things will make up one of your trig ratios. So here, we were given angle A. So in terms of angle A, we have to start with the angle because what we call the sides is based on the angle. So we're given angle A. In terms of angle A, B is the adjacent. So we were given the adjacent in terms of angle A. And then in terms of angle A, we were asked to find A over here, which is the opposite. So we're given A, we're given the adjacent to A, the side adjacent to A, and we're asked to find the side opposite of A. And then you ask yourself, okay, which trig function involves the adjacent and the opposite? That's tangent. So that tells us that tangent is the trig function that we need to use. So tangent of A is the opposite over the adjacent. And so then this relationship becomes like a formula where I plug the information into it. So I have tangent of 40 degrees equals A, because I don't know what that is, so I have to leave it as an A, over 150 centimeters. So take a second, make sure you see where that came from and went to. I'm just using my trig ratio that I've memorized and plugging the information I was given into it, and then leaving the thing I was asked to find as a variable. Now that we have that, what we have is a formula that an equation that we need to solve. And I'm going to go off kind of on a tangent, so to speak, and talk about a different equation. So this is, I'm making this up out of my head. Alright, so if I have this equation and I want to solve for x, well, x is being divided by 10, so I would do the opposite and multiply it by 10. But whatever I do to one side, I have to do to the other side. And so that's going to give me that 20 equals x. Oh, that's an 8. There, now it's an ugly x, because these 10s cancel off. Okay, so that's just reviewing a solving technique. That's the technique we're going to use to solve this equation, because even though it's a little uglier, it's the exact same configuration. Over here, tangent of 40 degrees, that's just a number. And we'll consult our calculator to get exactly what that number is, but it's just a number. And then the 150 centimeters is like my 10 in my other example, and the A is the variable I'm solving for. So what I need to do is multiply by 150 centimeters in order to get that 150 centimeters to cancel. But what I do on one side, I have to do on the other. So then it cancels on this side. And then that leaves me with A equal to 150 centimeters times tangent of 40 degrees. And that's a number, but we do need to ask our calculator about what that number is. So, and it's going to be an approximation, because when we put tangent of 40 degrees in, it doesn't come out exact, and so then we'll end up having to approximate it. I'm going to round to 2 decimal places. Alright, so when I punch that out on my calculator, I get 125.86 centimeters. Now, a couple things here. It is centimeters because, as we talked about before, the the trig functions are just naked numbers. We saw that their units cancel out on that. So that's just a naked number. And then we still have this centimeter here, and it doesn't get canceled out or go anywhere. So that's one way you can understand it as being centimeters. But the other thing is to realize that we found the length of A, which would be in the same units as the length of the other sides when we're doing this. So that's one thing I wanted to address. The other thing is I encourage you to take a second and punch this out on your calculator and make sure you're getting the same thing I'm getting, One, to make sure you know where the buttons are on your calculator and everything. But the other thing is there's two different ways to measure angles. One of them is degrees, which is what we're doing. The other is radians. And if your calculator is in radians mode, you will not get the right answers on these. So you want to make sure that it's in degree mode. And if it's in degree mode, this is what you should get. If you're having trouble with switching it from degree to radian, let me know and we can work on that. Alright, so what we did here is we were given the angle and a side, and we used it to find another side in a right triangle. This gets into more useful trig because oftentimes in life we can have situations where we know an angle and a side of a right triangle and we need to figure out the length of another side. And there's some applied problems that you can do with this that's very useful, unlike the previous example we did where we were just practicing the ratios. Let's look at another way of using this trig. Alright, so we have another triangle here, ABC, and they gave us the length of two of our sides. They're asking us to find the measure of angle B. So in this example we have two sides and we're using it to find the measure of angle B. In the previous example they gave us an angle and a side and we used it to find another side. So the way you start out on this is kind of the same way we did on the others, is we've got to take inventory of what we've been given and what we've been asked to find. Now you always start with the angle because the angle determines how we think of the other side. So we've been asked to find B. In terms of B, 12 inches is going to be the opposite. And then it's not really in terms of B, 13 inches is always going to be the hypotenuse. Okay, so we have angle B, and we have the opposite, and we have the hypotenuse. So then we have to think, okay, which one of our trig functions relates those three things? Which one of them deals with the opposite over the hypotenuse? And that's going to be sine. Sine of B is the opposite over the hypotenuse. So once we decide which trig ratio to use, we're going to use that like a formula and plug in what we know and leave what we've been asked to find as a variable. So what we have there is that sine of B equals 12 inches over 13 inches. And as we've seen, those inches are going to cancel out, leaving just a naked number. And we get sine of B equals 12/13. Okay, so far this is looking exactly like what we did in example 1. We've found the ratio, but we're not done yet. We were asked to find the measure of angle B. We've not done that. We've found the sine of B. So the sine of B and the measure of angle B are not the same thing. So what we need to do is get inside the sine, or break the sine away from B, so to speak. Now, I'm going to remind you of something you know in order to do this. So I'm just going to kind of make a side note over here that's not exactly related to what we've been doing. So I can use this thing that you know to explain what we need to do next. So if we have an equation, let's say we have 2x plus, that's too fancy, 2x equal to 10. So if we want to get x by itself, what we do is divide by 2. What we do to one side, we have to do to the other side. And the reason why is because x is being multiplied by 2. So we need to do the opposite operation in order to get x by itself. But the reason why that works is because when you apply the opposite operation, it causes that stuff to cancel out. And we're just left with x equal to 5. We do the math on the right side. But that opposite operation business is what kills off the stuff that's hanging out with x. Similarly, if I had x minus 5 equal to 13, then I'm subtracting 5, so to get that to go away, I need to add 5. And that gets it up to 0. But what I do to one side, I do to the other side. So to get x by itself, I am essentially always doing what we call the opposite operation. Alright, so, and those are opposite operations, but another word for them that we shelter people from is that they're the same thing as what's called the inverse operation, or I'll just say the inverse here. So if we invert something, we undo it or we flip it around or something like that. And so when we talk about trig functions, we don't talk about opposite operations because it's a function. So we start using this language of inverse. We need to take the inverse to undo it. So instead of multiplication, division being opposites, we have sine, and its opposite is inverse sine. So it's just a new language to say the same thing. So to undo something in these trig functions, we're going to apply the inverse, which is the same undoing we've been doing all along with equations. Now the notation for inverse sine is some of the worst notation in all of mathematics. So it's going to be, you write sine and then you put a little -1 up here. That's it. It's awful. And then what we're going to do is apply that to the left side of the function here, because we want to undo sine. So if we want to undo sine, we apply inverse sine to it. Now that you wouldn't say sine to the -1 because it's not an exponent, even though it looks like an exponent, which is why it's bad notation. It's just called inverse sine is what that is. And applying inverse sine to sine basically undoes the sine function that's around the angle, leaving us with just the angle, just like getting x by itself. Now, same rule applies. Whatever I do to one side, I need to also do to the other side. So I have to take this inverse sine and wrap it around my 12/13 that's on the right side. So that's what that looks like. Now on the left, that's like I'm taking a 2 and dividing by a 2 and leaving the x. So on the left, that's going to leave my b. And on the right, I have this mess, inverse sine of 12/13. And then that is just a number, and you enter it into your calculator to figure out what that number is. Now we're finding the measure of an angle, so it's going to be in degrees. I want to note that, because when you punch it in your calculator is not going to tell you it's degrees. It's just going to give you the number. Usually the inverse sine is the second function to sine on your calculator. So when I punch this out, I get that b is approximately equal to 67.38 degrees. Again, your calculator probably won't tell you the degree piece. You just have to know that's the units, just like your calculator doesn't tell you when it's inches or inches squared. So that's the idea of when you're given two sides and you need to use them to find an angle, you're going to have to use this inverse sine business to unwrap the sine, or to cancel out the sine is a way you could think of it, in order to get back to the angle you had before you signed it. Okay, so I kind of want to reflect back through some of this, because the first examples we did, these were just to emphasize that we knew how to find the trig ratios, but a trig ratio in and of itself isn't a useful piece of information. So for example, tangent of A equal to 5/12. That doesn't give us something physical on the triangle. It just tells us what the trig ratio is. And then we jump to where we were given a side and an angle, and we use that information to find another side. So now we found something actually physical on the triangle. So you can use this in, like, if you have a right triangle scenario, such as, like, you know, you're constructing something that is a right triangle, you can use this to find how long a side needs to be, because you found something physical on the triangle. So you do this when you're given a side and an angle, then you're going to use this process. The third example we did, we were given two sides and asked to find an angle. And again, that's something physical on the triangle that can be useful to find for various reasons. So which of these types of problems you do is going to be based on what you're given. Now, first of all, it all has to start with a right triangle. You can do trig on non-right triangles, but we're not getting into that depth, unfortunately. So you got to start with a right triangle. If you're given a side and an angle, you're going to use that to find a third side. If you're given two sides, you're going to use that to find an angle. And that's how trig works. Trig is a relationship between the two sides. If you're given two sides and asked to find a third side, that's the Pythagorean theorem. A lot of times people will confuse when to use which one. And so trig always is the one that is a relationship between sides and angles. So it's going to be talking about both of those when you're dealing with trig. Alright, go ahead and give some of these a try and see how you fare.